All right, the last part of 3-1, we will go over vertical motion. So here, our vertical motion example, we are given a position function with S above the ground of a ball thrown into the air from the top of a high cliff, where time is measured in seconds. So we're going to find the initial velocity. The initial velocity is going to require two things. First, a velocity function, which in this case will be the derivative of position. The rate of change of position is velocity, so the derivative of position is velocity. 2 times -16, derivative of 48t is just 48. Derivative of 160 is just 0. So there's my velocity function, and the velocity at time 0 is what we're talking about when we're asking about initial velocity. If I plug in 0 to this function, I would get 48. What are the units? It would be a position unit per time, which is feet per second in this case. Careful. Rate of change in position over change in time, position over time. At what time does the ball hit the ground? So in a vertical motion situation, hitting the ground will be the idea that the position equals 0. If our position function is above the ground, measuring how far something is above or below the ground, we're talking about the ground being 0, because the ground is 0 feet above the ground. So we're going to set this equal to 0. We're going to set the position function equal to 0. So now most students get worried about this and feel like they need their calculator. You don't. A lot of the examples on the AP test will allow you to factor out a GCF. With the front negative, we're going to factor out -16. That'll help clean things up on the inside. So we're getting t squared minus 3t minus 10. Now this is a very simple thing to factor. Minus 5 plus 2. Because 2 times -5 will give us -10. And -5 plus 2 will give us -3. So that gives us two answers, 5 and -2, 5 or -2. And in this example, with a lot of vertical motion, we will rule out negative time. If you were paying attention in the last lesson, or in the video on most of the examples of horizontal motion, we say we will use negative time. It's very context dependent. In this case, we're going to rule out -2 because t equals 0 will refer to the time when he threw the ball. So what does it mean to say before 2 seconds, before he threw the ball, it was on the ground? Now, maybe that makes sense in some circumstances, but he's on a high cliff. So even if the ball was on the ground of the cliff, it would not be on the ground below him. Just be careful when you're writing these answers that you're paying attention to the context. You will never get a problem in my class or on the AP test where the answer will conflict with your common sense notions of physics, whatever they are. If they're correct common sense notions, I suppose. Last. At what time does the ball reach its maximum height? So, an important fact for physics is that when we throw balls into the air, they come back down, this peak is where the velocity equals 0. That's just a fact of physics, motion on Earth. Once it starts to come back down to the ground, the velocity is changing from a positive velocity, which for vertical motion means we're going up, to a negative velocity, which for vertical motion means we're going down. So we know that the peak, the maximum height, will occur when v equals 0. So we're just going to set velocity equal to 0, negative 32t plus 48 equals 0, negative 32t equals negative 48. And it would be just fine with me if you left it unsimplified, like that. But we should always practice simplifying just in case we need to on the test for multiple choice. Divide both by 16, and you get our answer 3/2 seconds. Or 1.5 seconds. We're going to use decimals. So that's it. Those are the major differences with vertical motion. We're usually not going to make sense of negative time, usually. And we want to talk about how maximum height will mean the velocity equals 0. Thanks for your attention and your dedication. Good luck on the homework. Email me with any questions. Have a good day.